Guys, I welcome you back to another episode of Further Mathematics for SS2, and today we are going to be dealing with equations of motion. Now, I'll be doing an explanatory video on this course because you've probably not heard of this, but after I've explained this concept, you can head up to the physics playlist of my channel, and there are videos on equations of motion. So basically, I'll give the equations of motion and we'll solve questions on them. So we have three major equations of motion. So I will solve a question on it now. So the first equation of motion is just in case you've not heard of it in physics, V equals U plus AT. This is the first equation of motion. Then we also have the second equation of motion, S equals UT plus 1 over 2 AT square. And then we also have the third equation of motion, V square equals U square plus 2AS. Now these are the three major equations of motion. There are other equations of motion which are derived from this one or are derivators of these ones, but we'll basically be dealing with these ones. So let's start from let's do an example. So let me give an example here. We have an example here. So we have an example on the screen here. We have it as it's displayed on the screen right now. So on this example, we have it as a body moves at an initial velocity of 30 meters per second. It's also moving attains a velocity of 80 meters per second. It then continues at that velocity for some time and then decelerates in 1 minute. So we are told that the total time taken for a journey is 40 seconds and the total distance traveled is 2,550 kilometers. So now, if the time spent accelerating is half that of traveling at a constant velocity, calculate the acceleration. So yeah, this is a rather tricky question, but it's very easy to understand. It does not mean you will not be able to understand the question. So let's deal with the question categorically. So now we are told that a body starts moving at an initial velocity of 30 meters per second. You can screenshot that part so you can understand it better. So now, when we're talking about this, basically let's so it has an initial velocity of 30 meters per second, right? So we have it as U equals 30 meters per second. So and then we are told that its acceleration uniformly till it attains the velocity of 80 meters per second. So that means the V is equals to 80 meters per second. Then we're also told that it then continues at that velocity for some time and then accelerates uniformly to rest. So its total time taken for journey is 40 seconds. So T is 40 seconds. T is equal to 40 seconds. And then at the end of the day we have the and the total distance traveled is 2,550 kilometers. So D, which is S, equals 2,550 kilometers. Then also we are told that if the time spent accelerating is half that of time traveling, is half that of traveling at constant velocity, calculate the acceleration. So see, the time spent accelerating is half that of time at constant velocity. So T is equal to 1 over 2 T. Let this be the time spent at constant velocity. Now we will need what is known as a velocity time graph. So in this case, let's draw something like that. So I thought that the body starts moved at an initial velocity of 30 meters per second, right? And accelerates uniformly till it attains 80. So in our velocity time graph, we'll start from 30 here. So let's assume this is 30, then we'll take it up till we get to 80 here. So it's not drawn to scale, but it's still a very good representation of data. So and then we're told that it continues at that velocity for some time and decelerates uniformly to rest. So when it continues, it not decelerates uniformly to rest, right? So this is the velocity time graph. We're going to use this graph to achieve some very vital conclusions. So basically, at the end of the day, we have that. So at the end of the day, we have if the time spent acceleration is half that of time traveling at constant velocity. So that means this is the velocity time graph, right? So this is a graph of V against T. That means the time spent accelerating is half the time. So I think this is T. And then that means it's time spent accelerating. So this was when it was accelerating. This was when the graph was going upward. So this will be half of T. That's T over 2. So at the end of the day, we're told that the total time taken for a journey is 40 seconds. So that means let's assume this is unknown. That means this one will be equal to what? 40 minus T over 2. So that is good. I like the progress of this equation. So and we're looking for the acceleration, right? So now let's look at different points in this journey. So first point in this part of the journey, we have we will look at it carefully that this is a part of the journey where we have There's a fourth equation of motion which you can use for solving this equation. S equals u plus v over 2 times t. So we can use this for regions of the equations like this. So we can say but we don't know the distance yet. Okay, we have the total distance, which is 2,550 kilometers. 50 yes, kilometers. So that means when we add the distance for here, that is s1 plus s2 plus s3, we are going to get 2,550 kilometers. So at the end of the day, if we use this formula to calculate for s1, s3, we are going to get a value. Then we are going to get an equation which is equal to 2,550 kilometers. And when we solve, we'll get a value of t. So which is the time. And then from the time we can get the acceleration.